Hello everyone. This is one more session for digital to analog converter, that is DAC of LPC2148 microcontroller. So DAC of LPC2148 microcontroller is a very valuable resource because many of the microcontrollers has got internal ADCs, okay, but very few microcontroller has got internally available DACs. So in that sense I can say that LPC2148 has got one very much powerful resource internally available, that is DAC. Okay, so DAC is when we say digital to analog converter, it is one of the important resource inside LPC2148. Now because of this internal resource available as a DAC, we can generate any analog signal for the different applications. No need to have the external DAC and external analog signal. So whatever analog signal we require, we can just give the particular input to DAC, and we can generate the analog signal from LPC2148 itself. Now the DAC available inside LPC2148 has got these features. So it has got a 10-bit ADC, means digital input is 10-bit. So if you consider this DAC as one box, then I can say that this is 0, 1, 2, 3, like 9. 0 to 9 is 10. This is the input for a digital to analog converter, and obviously output is A out, that is one analog output is there for this DAC. Then few more features includes, it has got buffered output, it is even operated in power down mode, and it has got selectable speed. Okay, so after this brief discussion of so being a designer or being a system developer, we should know that how this DAC works. So DAC works in the following way. As since we know that this DAC is a 10-bit DAC, okay, so now what is the minimum input which I can have at the 10-bit ADC input? So these are the important specifications you have to understand and you have to keep in mind. Okay, now we are going to see what are the pins involved in DAC. So we can say one pin, that is A out, analog out. So pin number 9. Okay, it is involved in analog out. Pin 9 is also a pin of port 0's 25th pin. Okay, you all know port 0 is a 32-bit port. Okay, out of that this is 25th pin 9. Now you all know that what all functionalities port 0.25th pin is having. So P0.25 pin can act as number 1 port pin, that is P0.25. Secondly, it will act as analog to digital converter zeros channel number 4. It has got analog to digital converter also internally. So उस एनालॉग टू डिजिटल कन्वर्टर का चैनल नंबर 4 ऐसा भी ये पिन सर्व करती है, पिन नंबर 9. ओके, और तीसरा जो है वो ये पिन नंबर 9 और एक फंक्शन सर्व करती है, एंड दैट इज I can say something like this. Now when we use any peripheral device, our first job is to configure this P0.25 pin or pin number 9 into the particular function. Right now I want my pin to serve this function. So that is that configuration, or doing that configuration is our main first task in doing the further. So if 00 is written in pin select register, then P0.25 will, this pin number 9 will serve as port 0's 25th pin. If the 01 is written in the pin select register, then this same pin number 9 will act as channel number 4 for analog to digital converter. And if the same pin is given a status of 10, it will act as analog output of DAC. Now just to revise, I will say one more time that this LPC214 has got port 0, which is 32-bit. Okay, now for every port pin, every port pin can be configured in multiple functionalities, and for configuration of that multiple functionalities, every port pin is given as 2-bit space. Okay, so this is called register pin select 0. So pin select 0 0 0. Okay, these two zeros, 0 and 1, first two locations 0 1 is given to P0.0. Okay, so that here I can configure these 2 bits as maybe 00, maybe 01, maybe 10, or maybe 11. Okay, so either of the all possible logics, I can just put the numbers. Either this can be 00, 01, 10 and 11. So depending on whether it is 00, 01, 10 and 11, port 0 का 0 पिन जो है वो मल्टीपल फंक्शंस में से एक फंक्शन करेगा. वैसे ही अगर हम यहाँ से ऐसे गिनते आए अगर इसको, तो ये हमारा क्या है, पिन नंबर 9 है. तो यहाँ 0 के लिए 2 बिट है, फिर P0.1 के लिए जो है वो 2 बिट है, फिर P0.2 के लिए 2 बिट है. ऐसे करते करते यहाँ पे कहीं 0.9 के लिए 2 बिट होंगे, तो वो जो 2 बिट होंगे वहाँ पे हमें क्या डालना है, वहाँ पे हमें ये डालना है, दैट इज़ 1 and 0, right? So pin select 0 is a 32-bit register, right? So when it is a 32-bit register, how many pin configuration it can do? It can do 16 pin configuration, because every pin requires 2 bit. Okay, so likewise here last bit is what, P0.15. So here we can do that configuration. Now which register I am in need of? Pin select 0. So in pin select 0 register I have to write these 2 bits 1 0. Rest of the bits are 0 0 0 on this side and 0 0 0 on this side, and then we have to go ahead. Now special functions registers involved in this is only one special function register, that is DAC control register. That is DAC control register is only one special function register we have to study, whose name is DACR. Okay, so what is the configuration of DACR? So bit 0 to 5 reserved by manufacturer, then from bit 6 to bit 15. So DACR obviously 32-bit register, and then here what we have to write is 10-bit data, 10-bit digital data, right? Then so bias, okay, so let's go for algorithm. Okay, so let's go for the algorithm for DAC in LPC 2148. Step number 1, set pin number 9, or I can say pin number 9 means port 0 का 25th pin, to work as analog out. Okay, not to work as port pin, it has to work as analog out. So we have to do that setting. कौन से रजिस्टर में सेटिंग करना है आपको? हमें सेटिंग करना है पिन सिलेक्ट 0 register में. Okay, and then second number algorithmic step is write the digital input in the DACR. So DACR is what? Digital to analog conversion register. So in that register you just have to write that 10-bit input, and the position of that 10-bit input is 6 to 15. This is the like position where a 10-bit digital input can be written. And then finally what we have to do, get the A out. वो A out अपने खुद से ही कैलकुलेट करेगा डिजिटल इनपुट देने के बाद अप्रोप्रिएटली A आउट, एंड हमें बस वो लेना है और उसको हम स्टोर करेंगे, लाइक उसको हम यूज़ करेंगे, या उसको जहाँ पे भी एप्लीकेशन में हमें एनालॉग आउटपुट चाहिए, या हमें कुछ वेव फॉर्म जनरेट करना है PWM जैसे कुछ स्क्वायर वेव जनरेट करना है, ट्रायंगुलर वेव जनरेट करना है, उसको आगे हमें किसी आउटपुट डिवाइस को या एक्चुएटर को ड्राइव करने के लिए या एक्चुएटर को देने के लिए यूज़ करना है, तो फाइनली हम वो कर सकते हैं. सो वंस वी राइट लाइक दिस, देन लेट्स गो फॉर राइटिंग द प्रोग्राम. ओके, एल्गोरिदम का फर्स्ट स्टेप क्या था कि कॉन्फ़िगर P0.25, right? So configuration of P0.25 means LPC 2148 में that is one function, and that function is let's say we will just have to write one small function. That function is say void analog write, and what we will send to this function from the main function is nothing but a digital data. Okay, so I can write unsigned integer DAC data is what we have like defined in the main function, and then we are just passing that parameter to this function called as analog underscore write. And then what we write over here is first step, pin select 25 like P0.25 comma 02. So 02 means writing. Here I can say write 10 to P0.25. So it will act as a out pin, right? Then second step हमने क्या लिखा था? सेकेंड स्टेप हमने लिखा था सेंड डेटा. सेंड क्या? डिजिटल डेटा. ओके, सो डिजिटल डेटा सेंड करना है, मतलब क्या करना है? डी वी नो दैट वी हैव दैट DACR रजिस्टर इज इक्वल टू DAC डेटा. DAC डेटा क्या है? DAC डेटा ये हमें यहाँ पे हमने किसी मेन फंक्शन से जब इस फंक्शन को कॉल किया है एनालॉग राइट में, तब ये डेटा हमने पास किया है, और यही डेटा अब हम यहाँ पे ले लेंगे. ओके, सो DACR रजिस्टर में ये वाला डेटा जाएगा. बट whenever this data will go, this will not go like this. This will go by left shifting it 6 times, because we know that whatever is our data, that data has to be left shifted 6 times so that the data will fit from this position to this position, right? 10-bit data will be there, but otherwise that 10-bit data will be from these places. Okay, this. But I don't want that. What I want is, I want that 10-bit data to be shifted 6 positions in this direction so that it will fit from 6 to 15. And so this is the syntax to write like that, and then this function is over, because once the digital data is passed, then finally it is only a matter remaining in which we can just read the analog out pin, and then we can finally read the output of the digital to analog. And so the complete program, if you want to see, then the complete program would be something like this. This is including this library files, include lpc214x.h and then GPIO file and the timer file. Then this is the main program where I define one integer I, then writing while loop I is equal to 0 and calling the function analog write, which is this function. This function is this. So this is analog write function which I am calling, and where I am passing DAC data. So what data I am passing for the square wave? First time it is 0, then call delay, then 1, then call delay. So it will be a duty cycle 50% square waveform. Then I is equal to 0 calling the function by passing the parameter 0 over here, then calling the delay. Then I have put 1000, actually the maximum is 1023, so I just put the good maximum value, enough maximum value. Then again I have called analog write, and then here I have to write again one more time, calling a delay of 100 milliseconds, and then here our main program finishes. So then this will be a function which is, I could say, if we just copy this function over here in these lines, it will complete the whole program. Okay, and when you want to see that, or you wanted to like analyze the output, how that output analysis would be, the output analysis would be very simple, something like this. This you have to draw like LPC2148, maybe in Proteus, or maybe wherever you are doing this. So there what you have to do, there you have to take pin number 9, and then you just have to put it to the CRO or DSO, and then ds over CRO if you put, you'll be able to see the square wave of 50% duty cycle, and then you just measure the frequency of that waveform. This frequency of the waveform will be depending on the delay, okay, because delay, whenever I just put the output to logic 1 or the higher level, then give delay, then put the digital output to 0, which is equivalently converted into analog signal, and then give delay, then 1, then delay, and something like this is continuously happening. So okay, so here frequency is nothing but the function of delay, okay. So the long delays you give, the frequency will be lower, the short delays you give, the frequency will be higher. So in the very similar way, in the very simple way, you just have to see the output waveform, okay. So this completes, this is a very simple topic. This completes the interfacing, but not this is not external interfacing of DAC. You can say not interfacing, you can say programming of digital to analog converter in the LPC 214. Thank you very much. This much literature is like enough, and even I have written these all things in the notes also. You can refer to that, and then you can prepare your own document which will be explaining this. If this question comes, you will be able to explain this in appropriate detail.